so long as physical state of conductor remains constant. When we say physical state of conductor, that means length, breadth, volume, temperature, pressure. Those are called external conditions. So long as physical state of conductor remains constant, the current flowing through a conductor, current flowing through a conductor is directly proportional to the potential difference maintained across the conductor. So long as physical state of conductor remains constant, the current flowing through conductor is directly proportional to potential difference maintained across the conductor. That is I proportional to V. Therefore, V proportional to I. Therefore, V equal to IR, where R is a constant called as resistance of conductor. Constant called as resistance of conductor. Its SI unit is ohms. Symbolically, it is denoted by Greek letter ohm. Now you are complete. Please fill that. If completed, tell me so that I can teach you further. Copy.
Done, sir.
Define 1 ohm. Define 1 ohm. Since R equals to V upon I, therefore 1 ohm equal to 1 volt upon 1 ampere. Thus, 1 ohm is defined as resistance offered to flow of ampere current, then potential difference of 1 volt is maintained across conductor. Resistance offered to flow of 1 ampere current when potential difference of 1 volt is maintained across conductor. That is called 1 ohm. Next I have written conductance. Resistance means it will oppose. Conductance means it will help. So the reciprocal of resistance is called as conductance. Okay, just copy it in it. Then we'll see it unit.
Done.
It is given by K equal to 1 upon R. Its SI unit is Siemens or mho or ohm raised to minus 1 or inverted omega or omega raised to minus 1. They can give any one symbolic notation sometime in empty. Right. Done, I think, correct? Yeah. It's completed. Hello, completed till this?
One sec.
Okay, I'm writing graph of V versus I. Since you have taken maths, you might be knowing what is graph of y equal to mx. Is it line or circle or parabola or ellipse or hyperbola? Y equal to mx. Yes, y equals to mx graph is what?
I don't know.
You have done chapter called straight line in maths.
Yeah.
What is equation of straight line?
Y equals to mx plus c.
So that means if it is not c means still straight line, but it passes through origin.
Yeah.
So that means you are knowing. So y equals to
Oh,
mx is a straight line passing through origin. Okay. It will be like this now, this line,
yeah.
where m means slope. If it is positive, it makes acute angle. If negative, it will make obtuse angle. And mx plus c means it will cut y intercept. So whenever you see linear equation, it is straight line, correct?
Yeah.
Okay. In our case, what is v? Is it ir? I want v along y axis and I along x axis. So this will be like y equal to mx. So can I say it will be a straight line because it is similar to my equation in maths for a straight line passing through origin. So v equal to ir. If v is along y, I is along x, it will be a straight line passing through origin as shown. Passing through origin as shown. And slope will become m. M is comparable to r. Y equal to mx, therefore it is like a straight line passing through origin. Slope by comparison will be r. So if y axis you take for potential and x axis for current, this is v I, this is straight line passing through origin. So slope of vi graph equals to resistance. So if this angle is theta, you can say tan theta equal to r. Please copy this mark. Copy till this. Again, if you complete, please tell me. हेलो हाँ मैडम बोलिए मैंने भेजा ना मैडम लेकिन आपका ये नंबर शायद व्हाट्सएप पे नहीं दिख रहा है मुझे हाँ यस क्योंकि मैंने ना कल रामानंद जी से बात हुआ तो उनको मैंने फॉरवर्ड किया नहीं, मैं आपको भी कर देता हूँ आप कोई बात नहीं आप व्हाट्सएप नंबर भेज दीजिए मैं कर देता हूँ थैंक यू उसमें लिखा है इस तरह की कोई कर देता हूँ मैं 2 मिनट में करता हूँ
Done.
Now followed na, that means y equal to mx to the straight line. Vectors on which resistance depends. Vectors on which resistance. Oral, where you stay? Kandivali or Goregaon?
Goregaon.
From Goregaon, have you ever traveled to Churchgate?
No, sir.
No? Till Bandra?
I haven't traveled to Churchgate, but not alone.
Ah, with vehicle. Have you traveled in vehicle?
Yeah, sir.
Okay. So when you travel from Goregaon to Bandra or Goregaon to Churchgate, where you will have more obstruction or more signals coming between Goregaon to Bandra or Goregaon to Churchgate?
Churchgate.
Yes. Actually, everywhere same signal will come, red, green, orange. As you were telling me about this lamp, signal post. So more signal post will come if I travel too far distance. So can I say I stop several times if I travel farther distance as compared to the shorter distance? So resistance is directly proportional to length or inversely proportional to length. What do you suggest?
Direct.
Directly proportional. Resistance of conductor is directly proportional to length. That is, R is proportional to L. If this is one door and this is another door, in which case we can move easily? Both are having same area where we can move easily.
Small.
In both it will be same because area same rakha hai. But if I have one larger area, then here it is more easily you can move, no? If we can move,
Yeah.
if we can move easily, that means resistance has decreased or resistance has increased?
Decrease.
Decrease. So can I say resistance of conductor is inversely proportional to resistance of conductor is inversely proportional to area of cross section. Resistance of conductor is inversely proportional to area of cross section. That is R proportional 1 by A. Third, it depends upon material. Fourth, it depends upon temperature. So there are four factors on which it depends: length, area, material, temperature. Please copy this four factor.
Done.
Okay. Specific resistance or resistivity. Specific resistance or resistivity. Since R is proportional to L upon A, so R will be rho L upon A, where rho is a constant called as specific resistance or resistivity. If L is 1 meter, A becomes 1 meter square, then we can say R is same as rho. If L is 1, area is 1 meter square, then R is same as rho. Rho is specific resistance. I can say equal to means is defined as resistance of a conductor having unit length and unit area of cross section. So we can say thus specific resistance is defined as the resistance. Specific resistance is defined as resistance for unit length, comma, unit area of cross section of conductor. Unit length and unit area of cross section of conductor. Its SI unit is R is ohm, specific resistance we want, length is meter, area meter square. So it will be ohm meter. Its SI unit is ohm meter. Ohm, omega, and now copy till this. What is reciprocal of resistance? Just now we wrote reciprocal of resistance. Hello? What is reciprocal of resistance? Reciprocal of resistance is conductance, we wrote, correct? So reciprocal of resistivity is called as conductivity. Conductivity. The reciprocal of resistivity. Resistivity and specific resistance are same. Is called as conductivity. Just copy this two line. Yeah. कौन बोले? अरे अच्छा, मैंने एक्चुअली कॉल किया था, फिर बाद में कट कर दिया था। हाँ, यस यस यस, हाँ जैसे ठीक है ना? नहीं पर पेरेंट, अच्छा ठीक है, उसके लिए फोन किया था। तो बहुत दिन से तो नंबर मिल नहीं रहा था, तो मेरे दूसरे मोबाइल में ढूंढा मैंने, तो देखा। और अभी इंडिया में हो क्या अब्रॉड? अच्छा, वर्क वर्क फ्रॉम होम। अच्छा, थाने ना? करता हूँ आधे पौने घंटे में। ओके, थैंक यू। The reciprocal of resistivity is called as conductivity. It is given by sigma equals to 1 by rho. Its SI unit is ohm meter raised to minus 1 or omega meter raised to minus 1 or Siemens meter raised to minus 1 or mho meter raised to minus 1. Now copy conductivity till this. Yes, done. Oral. Temperature dependence of resistance. temperature dependence of resistance. Experimentally, it is found that in case of metals, resistance increases with increase in temperature. Resistance increases with increase in temperature. Let R0, RT be the resistances of conductor at 0 degrees Celsius, T degrees Celsius respectively. Therefore, increase in resistance will be RT minus R0, because we wrote resistance increases with increase in temperature. So increase in resistance will be RT minus R0. It is found that RT minus R0 is directly proportional to, that means increase in resistance is directly proportional to, is directly proportional to its original resistance at 0 degrees Celsius and rise in temperature delta T. Therefore, RT minus R0 is proportional to R0 delta T. So we can say RT minus R0 equals to alpha R0 delta T, where alpha is constant called as temperature coefficient of resistance. Alpha is constant called as temperature coefficient of resistance. Just write this much, then two more lines we have to write. Therefore, we can say RT equal to R0 plus alpha R0. RT equals to R0, 1 plus alpha delta. This is temperature dependent. So, Aditya, you can hear me? Hello, Aditya? Hello? Hello? Hello, Aditya?